Good morning to everyone. Today I'm going to present the topic temperature measurement. Temperature is one of the most frequently measured physical quantities in engineering, science, medicine, and industrial processes. Accurate temperature measurements helps maintain safety, improve efficiency, and ensure product quality in various applications. Temperature is a measure what is temperature? Temperature is a measure of the degree of hotness or coldness of a body. It indicates a thermal condition of an object and determines the direction of heat flow. Heat always flows from a region of higher temperature to a region of lower temperature. Temperature is a fundamental physical parameter used in almost every engineering system. The SI unit of temperature is the Kelvin, represented by the symbol K. Understanding temperature is essential because it directly affects the performance, efficiency, and safety of many industrial processes. Temperatures can be expressed using different scales. The three most commonly used scales are Celsius scale, Fahrenheit scale, Kelvin scale. In the Celsius scale, the water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. In the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The Kelvin scale is the SI temperature scale where water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. Among these scales, Kelvin is commonly used in scientific and energy and engineering calculations because it starts from absolute zero. Temperature measurement is extremely important in many fields. In power plants, the temperature monitoring ensures efficient operation of boilers, turbines, and generators. Manufacturing industries use temperature control to maintain product quality and process efficiency. Chemical industries require accurate temperature measurement to ensure proper reaction conditions. HVAC systems depend on temperature monitoring for maintaining comfortable environmental conditions. Medical diagnostics use temperature measurements to monitor patient health. Food and beverage industries rely on uh, temperature control to ensure product safety and quality. Thus, temperature measurement is essential for process control, safety, and quality assurance. Temperature sensors are broadly classified into two categories: contact type sensors and non-contact type sensors. Contact sensors directly touch the objects being measured. Examples: mercury thermometers, bimetallic thermometers, RTDs, thermistors, thermocouples. Non-contact sensor measure temperature without physical contact. Example, infrared thermometers, radiation pyrometers. The choice of sensor depends on the application, required accuracy, temperature range, and environmental conditions. A thermocouple is the one of the most widely used temperature sensor. It operates based on the Seebeck effect, where a voltage is generated when two dissimilar metals are joined together and subjected to a temperature difference. The generated voltage is proportional to the temperature difference and can be measured to determine temperature. Thermocouples offer several advantages: wide temperature measurement range, rapid condition, construction, low cost, and fast response. Because of these benefits, thermocouples are extensively used in industrial applications. A resistance temperature detector, commonly called RTD, operates on the principle that the electrical resistance of a metal changes with the temperature. As temperature increases, the resistance of the metal also increases. Platinum is the most commonly used material because of its stability and accuracy. The main advantages of RTDs are high measurement accuracy, excellent stability, good repeatability, long-term reliability. RTDs are widely used in laboratories and industrial process control systems where high accuracy is required. A thermistor is a semiconductor-based temperature sensor. Its resistance changes significantly with temperature, making it highly sensitive. Thermistors are classified into two types: NTC thermistors. Resistance decreases as temperature increases. PTC thermitors. Resistance increases as temperature increases. Because of their high sensitivity and low cost, thermistors are commonly used in electronic circuits, medical devices, battery protection systems, and temperature compensation circuits. Infrared thermometers and pyrometers are examples of non-contact temperature measuring instruments. They work by detecting the thermal radiation emitted by an object and converting it into a temperature reading. Since no physical contact is required, these requirements are ideal for measuring temperatures of moving objects. Hazardous materials are extremely hot surfaces. Common applications are industrial furnaces, molten metal processing, high temperature manufacturing processes, and electrical equipment inspection. These instruments provide fast and safe temperature measurements. This table compares different temperature sensors based on accuracy, measurement range, and cost. Thermocouples have a very wide temperature range and low cost but moderate accuracy. RTDs offer high accuracy and stability but are relatively inexpensive. Thermistors provide very high sensitivity and accuracy for lower temperature ranges at low cost. Infrared thermometers offer high accuracy and wide measurement ranges without requiring physical contact. Therefore, the selection of the temperature sensor depends on the specific application requirements such as temperature range, accuracy, response time, and budget. In this presentation, we discussed the fundamentals of temperature measurement, temperature scales, the need for temperature monitoring, different types of temperature sensors and their operating principles and applications. Temperature measurement plays a crucial role in industrial automation, healthcare, research and process control systems. I hope this presentation has give you a clear understanding of temperature measuring techniques and instruments. Thank you.